Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I'm Arif and I welcome you all to the next session of the lecture series on Internet Working with Linux. Our today's session will be on MySQL Server, its installation, configuration, user management, and a bit of database management as well. Well, dear students, MySQL is a famous relational database management system, and its first version was released in 1995. The My part of the name MySQL is the name of Michael Monte's daughter, who is the co-founder of MySQL. And you all know the SQL part means Structured Query Language. In 2008, Sun Microsystem purchased MySQL, and in 2010, Sun Microsystem was acquired by Oracle Corporation. So, currently MySQL is maintained by Oracle Corporation, and its binaries are available for Microsoft Windows, Linux, Mac, FreeBSD, NetBSD, and many other platforms. MySQL offers a variety of database connectors, including ADO.NET, ODBC, JDBC, C and C++, Python, Perl, Ruby, and PHP. MySQL is a central component of LAMP, an open source web application software stack, which we are going to discuss in our next session, inshallah. So let us start playing with Ubuntu Server. Right now I am on my Ubuntu Server machine. Hostname is Ubuntu Server. IP address is 192.168.1.100. We can of course install MySQL Server using apt-get. But let us first do apt-cache. apt-cache is used to display information stored in apt's internal database. Let me do apt-cache search MySQL-server. Excuse me. So there are a lot of database servers that are being displayed. One is MySQL Server, another is MariaDB. Well, what is MariaDB? You can say that right now it is the open source version of MySQL. Actually, in 2010, when MySQL was acquired by Oracle Corporation, one of the original developers of MySQL, Michael Monte, decided to create a fork of MySQL with the name of MariaDB. Till date, all the applications that use MySQL can switch to MariaDB without any issue. If you see further down, we have the Percona server as well. This is also a relational database management system. It is free and fully compatible replacement for Oracle MySQL. People said that it is designed to excel for cloud computing. However, I don't want to comment on that as. But let us not involve ourselves in the discussion of which DBMS is better, MySQL or MariaDB or MongoDB or Microsoft SQL or Oracle Informix, Sybase or Teradata. But dear students, rest assured, if you know one of these database management system in depth, it is just a weekend's effort to switch to another database management system. Let me clear screen and do apt-get install MySQL-server, which is already installed and latest version. When you will be installing it for the first time, it will prompt you for the root password, a new user root for MySQL, and it will by default bind the MySQL server to the IP address of 127.0.0.1. Let me check out the port on which MySQL server will listen, and let me cat etc services file, grab MySQL from that file. You can see it will listen on port 3306. Well, forget about MySQL proxy right now. It is basically an application that provides communication between one or more SQL servers and one or more SQL clients. Let us simply start the service by systemctl start mysql.service excuse me, and let me check the status now. It is up and running, and let me grep netstat-ant and grep 3306, and you can see MySQL Server is listing on port 3306. However, due to this 127.0.0.1, you can log into MySQL only from the local machine. This is the default setting. We can always change that. Let me change that first. Let me open the configuration file of MySQL from mysql.conf.d directory, and in that mysql.cnf file. There are a lot of configurations in this file. Right now I just want to comment this bind address 127.0.0.1, and instead I want to bind to 0.0.0.0. That means that MySQL Server should be able to listen on any incoming request from any machine. Let's keep the rest of the configuration as default, save and quit. Let me do systemctl restart mysql.service, and let me do now netstat again, and you can see now there is 0.0.0.0, so we can log in to this MySQL server from some remote machine as well. Okay, so let me do MySQL. This is a client program, and let me log in using the user root with password -p means password. Remember, this root is the root user that you created during the installation of MySQL Server. This root user has nothing to do with the root user of Ubuntu Server. Let me give the password. We are in. We are having the MySQL prompt. Let me quit right now. We will see what all commands do we have that we can give on the MySQL prompt in a short while. Please do see the main page of MySQL daemon, and do see the main page of MySQL client, MySQL. And if you want to see the path of MySQL daemon, it is usr sbin mysqld, and if you want to see the path where MySQL client is installed, so that is usr bin mysql. Okay, dear students, let me move on to our Kali machine. Let me sudo if config, and the IP address of this machine is 192.168.1.101. Suppose from this machine, if I want to log in to our MySQL server, first I will do SSH. I will do SSH, and I will log into the Ubuntu server machine. SSH Arif at 192.168.1.100. Remember, this Arif is a user that exists on Ubuntu server. You might have observed that it has not prompted me for the password. This is for authentication. This is because in our session of SSH, we have configured that Arif should be able to log in with authentication of SSL keys. Anyways, right now I am on the Ubuntu server. Okay, from here I can always do again mysql -u, the username root -p, and there I go. So I am on the MySQL prompt. Remember, this is one way to log in remotely, that is using SSH. Let me exit. Let me exit again. I'm back onto the Kali machine now. Dear students, what if there is a user who do not have a local account on Ubuntu server? That is, he cannot do SSH from Kali to Ubuntu server. But that user still wants to log in on MySQL server, which is running on the Ubuntu server machine. So for that, what I need to do is, I first need to install MySQL client on this Kali machine. Let me clear screen and let me do sudo apt-get install mysql-client. Okay, let me do apt cache to find out the exact package name. Sudo apt-cache search mysql-client. Name is default MySQL client. Sudo apt install default-mysql-client. So this is the newest version. This is installed. That's fine. Okay, dear students, now I have installed MySQL client on the Kali machine, and on the Ubuntu server machine we have the MySQL server installed. Let us now first create an administrative user on MySQL server other than root. Root is the one that we have created during installation. For that, let me log into MySQL as root user. And let me give the command create user. Let's say the name of the user is user1. At this %sign means this user1 can log in from any machine remotely. If I write on localhost over here, this user1 will only be able to log in to MySQL server from localhost. Anyway, identified by the password. So let's suppose this is the password. So the user is created, and since I want that this user should have administrative privileges, so let me grant him all privileges on all the databases and all the tables. User1 at this %sign, and also give him grant option. That means he can create more users and grant them options. I will talk about these commands in detail later on. But right now, remember, there is an administrative user with the name of user1 that has been created on MySQL server. Now this user can log in remotely and can perform all sort of administrative tasks on MySQL server. Let me come back over here and let me log into the MySQL server using MySQL client program with user1 -p means the password, and I need to give the host name as well. -h means the host name, 192.168.1.100, and I need to give the password, and there I go. Okay, now I will be performing all the remaining tasks from this Kali machine, as this terminal is a little bit more readable as compared to the black screen of Ubuntu server machine. If you wish, you can always do these tasks locally from Ubuntu server machine. Okay, let's see the existing databases that exist on MySQL server right now. Show databases. So there are four databases that are available right now: Information Schema, MySQL Performance Schema, and SYS. And of our interest right now is the MySQL database. And MySQL database is a system database that contains tables which store information required by MySQL server to run properly. Okay. Right now over here you can see on the prompt none. That means no database is selected right now. Let me say that I want to use the database MySQL. You can see the database has changed. Right now the MySQL database has been loaded. Let me say show tables. It will display all the tables that are there in MySQL. There are a lot of tables you can see. Tables related to health, there are tables related to time zones, and there is a table that is user. Right now, the table of our interest is user. Since we are mainly concerned about user management, so we will restrict ourselves to this user table. Okay. Let us first see the structure of this table. That is user, and let me say describe user. Okay, let me reduce the font a little bit. Okay, well, you can see this user table has a lot of fields, and they're shown over here in this column, and their data type is shown over here. The null constraint, the primary key, default values, if any, and any other extra information. Well, the field which we are interested right now is the host field. This field contains the IP address of a host, or maybe a percentage sign. That means every IP, or maybe a local host. This field user, that contains the name of the user. Then we have a lot of privileges, and these privileges can have value of no or yes, and the default value you can see for all these privileges is no. That is, any new user will have no privilege by default. And finally, this is the other field of this table in which I'm interested right now, that is the authentication string. And this authentication string actually stores the password for the user. Okay, so now let us view the contents of this table. Select all from user. Oops. Okay, so there are a lot of data that cannot be displayed on the screen right now. Let me say select user host authentication underscore string. These are the three fields which we are interested right now from user. Let me zoom it a little bit. You can see there are right now 1, 2, 3, 4, 5 users. This root user is the user which was created during installation, and he can log in from the local host only. This user one is the user which we have just created, and he can log in from any machine. As far as this mysql.session, this user is concerned, this is used by plugins to access the server. mysql.sys is basically the definer of the system schema of the objects. Both these users accounts are actually locked so that it cannot be used for client connections. Right now we are user 1, and this is the administrative user, so we can do a lot of things using as being logged in as this user. If you just want to see all the users who exist in MySQL server, you can simply say select user from the table user. Okay, so these are the users. And if you want to see the current user who has logged in, you can say select user, and you can use this function. It will tell you this is the user whose account has been used to log in right now. Okay, well, let me show you the privileges as well of this user 1. Select user and the create privilege column and the grant privilege column and the alter privilege column and the drop privilege column. Well, that's enough. From the table user, where user is equal to user 1. Okay, so I just want to see these columns from the user table. oops, let me repeat this. Select user, create privilege column, grant privilege column, alter privilege column. Then we have the drop privilege column, priv from. Okay, we have a typo over here. From. Okay. So this time you can see user 1 has a yes for create privileges, yes for grant privileges, yes for alter privileges, and yes for drop privileges, and a yes for other privileges as well that are there in that column because we have just created it using this way. Another way of seeing all this is you can say show grants for user 1. Here you can see that grant all privileges on all the databases and all the tables to this user and with grant option. Now let us try to create another user, and let's create another user, create user, and let's name that user Mars, and let me say that the user Mars can log in from any machine suppose and identified by this password. So this user has been created, and let me grant him some privileges, and I don't want him to be administrator. Let me grant him select, insert, update on a database. Let's suppose the database name is MySQL, and all the tables of that database to Mars at this, and that's okay. So this user has been created, and let me check show grants for Mars, and you can see that he has the usage privilege on all the databases, all the tables, and he has select, insert, update privileges on the MySQL database. Okay, let me move on to this terminal on the Kali machine. Let me use MySQL, and let's suppose that Mars wants to log in now. -p-h 192.168.1.100. It will prompt for password of Mars, and there you go. Mars is there. Well, if Mars wants to change his own password, he can always do that using the alter user statement. Mars identified by. So if I do this, sorry for the typo again, the password of Mars has been changed, and let us quit Mars. Let us shift back to this terminal where the administrative user has been logged in. Well, the administrator can always lock different users. Let's suppose alter user Mars account lock. Now the user Mars is logged. If the user Mars now tries to log in, it will be said that your account is locked. Let me come back and let me unlock Mars, alter user Mars account unlock, and if I come over here and try to log in as Mars, you can see Mars has successfully logged in. Let me exit and let me clear screen. Let me come back over here. If I do select all from user, let me select only the user names from the table user. You can see Mars is also there. The administrator can always delete the accounts. You can delete it using the drop statement, drop user Mars, And now if we see the users, you can see Maj is no more there. Okay, dear students, we are done with a bit of user management part. But if you are stuck on doing something that I have not discussed in the user management part, uh, you can always get help using the help command. MySQL has a very good sort of help command. If I type help, you can see there are a lot of commands you can use: exit to exit, quit to quit, and use to use another database. You can use these commands related to MySQL client. If you want to do with the help of MySQL server, you can type in help, let's suppose contents. If I type help contents, there are a lot of categories that are being displayed in front of you. For example, the account management, let me say help account management. You can see these are the commands that are available to you for account management. And let me say, let's suppose create user. I want to get help about create user command. So there is very extensive help with examples. You can see this example is a user has been created and his password setting has also been made so that the password expires after 180 days. And in this example one, the password expires immediately. So the student is required to change his password for the first time when he logs in. Okay, dear students, let's change gear. Let me clear screen. And if you want to clear screen, clear is the shell command. It will not clear the screen. So if you want to execute a shell command, you can always say system clear. This will execute the command for you. Okay, now let's create some databases and create tables in them. Let us first see the existing databases again. Show databases. So these are the 4 standard databases that exist. And if you want to create a database, you can always use create database on the name of the database. Let's suppose db1. This database has been created. Let me create another base, temp db2, and let me show the databases. You can see the temp db1 and temp db2. These 2 databases have been created. Okay, let me clear screen. If you want to delete our database, let me use system clear. If you want to delete a database, you can always use drop database and the name of the database to be deleted, db1 and db2. Let me say show databases, and you can say the temp db1 and temp db2 is no more there. Okay, and now we need to see how can we create tables within a database. Okay, so before I do creation of the databases and tables in detail, let me talk about the design procedure of database. Well, dear students, I will not go into the details of designing procedure of a database, but just for review, let me brush up some very important concepts. Well, during the analysis phase, a database designer identify the entities, their attributes, and the relationship that exist among different entities. These relationships can be one-to-one, one-to-many, and many-to-many. An example of one-to-one relationship is the relationship between the roll number and student. So we normally make roll number a field of the student table. So that is not an issue. However, the most common relationship type that we come across while designing a database is one-to-many. This is also called the parent-child relationship. For example, consider the relationship between a department and an employee. Remember, a department can have many employees. So department becomes the parent table and the employee becomes the child table. And these 2 tables must be related using something that is known as foreign key. So the primary key of the department table is kept in the employee table as foreign key. And just to brush up, we all know that a primary key is an attribute of an entity or maybe a field in a table that uniquely identifies all the records in that table, and it can't be null. Similarly, a foreign key is used to relate two or more tables, and a foreign key is normally a primary key in one table. It can be null, and it doesn't have to be unique like the primary key. Fine. Let's talk about the third relationship type, that is many to many. Dear students, if this relationship exists in your database, that means your database is not normalized yet. So you need to follow the procedure of normalization, which is the process of converting complex data structures into simple and stable data structures. And this can be done by removing repeating groups, partial dependencies, and transitive dependencies. Well, I think that is enough of theory. Let us move on to the SQL prompt and create some tables. Okay. Remember, right now I am on the Kali terminal and I have logged into MySQL server that is running on Ubuntu server as user1, who has all the privileges to perform data definition commands. Let me select user. You can see I'm user1 right now. And since I want to create tables in a database, I need to create a database first. There is no database in which I can work right now. Create database. Let me name it temp1. You can see this database is created. Right now you can see on this prompt I'm using the MySQL database. So if I create a table over here, that table will be created in MySQL database. Let me use temp1. Sorry, it is not temp, it is temp1. Okay, now you can see the database is changed. I am on the temp1 database. I want to create table. So if you want to create table, you can get help about contents, and over here we can see the data definition. Let me get help about data definition. Well, there are a lot of topics about data definition. Right now I'm interested in create table. So this is the help page for create table. Whenever you are stuck up, please, you must know how to get help in MySQL. That will help you a lot. Okay, let's create table. Create table department. And let me name the fields of this table department number and its data type int unsigned. There are a lot of data types that are available to you. Let me talk about data types on this terminal. Let me log in MySQL -u. Let me be user1. Let me log in as user1 from this machine. Again, as a second instance, -h192.168.1.100. Okay, and let me get help about data types. Okay, so these are lots and lots of data types that are available to you, and this is the data type int. So let me get help on int. You can see that this is a normal size integer. The signed range is from this to this. The unsigned range is from this to this. So whenever you are using some data type or you are confused, you can get help about that particular data type. Let's come back. So the first field name is department number. Its data type is int unsigned. Let me put a constraint on it. That is, it cannot be null. If you do not put this, by default, the null constraint is applied to every field of a table. Since this will be the primary key, so let me do auto increment, and this attribute is used to generate a unique number for every new row, and the user do not have to specify a value for this field whenever he or she is inserting data into this table. And let me say, and this is going to be the primary key. Put a comma, move on to the next line. The next field is department name. And let me give the data type as varchar 30. Let me talk about varchar. Okay. Help varchar. Oops. Varchar is basically a variable length string. Okay, you can read this out. And if I say help, simply char, so a fixed length string. So I'm using variable length string over here. Details you can read at time of your ease. Not null constraint. And it's okay. And finally, another field, that is the location, having the data type again varchar and not null. Sorry for the typos. Let me close this, and we have created this table successfully. Right, dear students, since we have created this table, let me use show table statement and find out what all tables are there in this database temp1. So there is one table, that is department, and let me say describe department. You can see this is the description of this table department. It has three fields: department number, department name, location. These are the data types, null constraints, the key, that is the primary key, department number is the primary key, default values, and so on. Okay, well, if you want to change the name of a table, you can use the command rename table. Let me name it to DEPT, and let me say show tables. Now you can see the name of the department has been changed. Okay, well, let me clear screen, say describe department. It has three fields. Let's suppose I just want to add a new column in this table. So let me use alter table, department, add a column. Let's name it test column. Give its data type small int, let's suppose, and let me say that it should be added after the name. And let me describe department again. You can see this test column has been created over here with the data type of small int, and it has been created after the department name. You can always drop this column if you want to. Alter table department, drop test call. Okay, alter table DEPT, and we just want to drop test column, COLUMN, the complete name. Okay, let me describe department again. You can see that is no more there. Let us assign our default value to a field. Let's suppose that I want to assign a default value to the location field. This is a location field, and I want to assign it a default value. Let me use alter table again. The name of the table is DEPT. Modify LOC varchar 30 default. Let's suppose the default value is nowhere. So this is going to be the default value. Let me describe department, and this time you can see the default value nowhere over here. Similarly, Dear students, you can add constraints, you can disable constraints, you can drop constraints, and if you want to get help, you can use help alter table. So there is a lot of help that is available over here. Let me talk about the constraints. Basically, a constraint is used to limit the type of data that can go into a table, and thus ensuring the accuracy and reliability of the data. If during insertion operation there is any violation between the constraint and the data action, the action is aborted. A lot of constraints that you can use. One is not null or null. Other is unique. By unique, this constraint, when applied on a column, ensures that all values in that column are different. Default we have just used. You can use index. Index is used to create and retrieve data from database very quickly. We apply index constraint on different fields, normally on the primary key, which is also a constraint. This index is implicitly applied. Similarly, the other constraint is foreign key, and there is another constraint that is check, that checks all the values in a column must specify a specific condition. Let us keep moving ahead, and after the data definition commands, see what we need to learn about the data manipulation commands. Let me again use help contents. Let me say help manipulation. So these are the different data manipulation commands. Right now I'm interested in delete, insert, and update. So you can get help about that. Let me get help about insert first. So please read this page. Let me do that for you. Let me insert some data in the department table using insert table statement. So we will use insert into DEPT. So this is the name of the table in which we want to insert data. Value, and the first value is the primary key, so I'm not going to insert. And the next name is the name of the department. Let's suppose this is accounts, and next is the location, and let's suppose this is Karachi. So this record has been entered. Let me enter another record, a second record, and let's suppose the department name is sales, and its location is, let's suppose, Lahore. Oh, we have now these two records over there. Let me see them. Select all from DPT. You can see these three records are there, and you can see the department number field is automatically incremented. Let us now update our record, and let us change the department name from accounts to, let's suppose, defense. So update department, set dname is equal to defense, where, let me use department number, where department number is equal to 1. So you can see now the department number has been changed from accounts to defense. Let us delete a record now. Delete from department, where department number is equal to, let's suppose, 2. I want to delete the sales department. Let me select. You can see department 2, sales department, has been deleted. You can always truncate a table. By truncating, I mean delete all the data that's there in a table. Truncate table department, and let me use select again. You can see there is no data in this table. describe department. You can see that however we have deleted all the data, but the structure of the table is still there. The table still exists. Let me delete the table as well. Drop table department. Now let me show you the tables in temp database. There is no table in the temp database. Alright, dear students, we have done insertion, updation and deletion of records in a table, and we have deleted the table as well. The next task we need to see is how to use different select statements and retrieve data from a database. Well, to create a database that is creating tables, inserting records on those tables may take a bit of time if I do it on this terminal. So what I have done is I have already created a script file that can save time to us. Let me do system pwd. Okay, right now I am in this directory. Let me do system ls. So this is the listing of the local directory, and I have this script file videodb.sql that I've created for this purpose. Let me open it in Vim. Videodb.sql. Okay, so this is a very simple file. It is using the same statements which we have used up till now. Drop database if exists. If this database already exists, it will drop this database, and then it will create this database, and then use videodb means convert the current DB to this. Create table department. We have already created this department table. Let me move down, and over here I have created the table employee. So we have different fields of the employee table. EMP number is the primary key. We have e-name, job of the person, hire date, manager, salary, commission, and then we have a department number key over here. This is actually the foreign key. The primary key in the department table is placed over here. Okay, this line adds the foreign key constraint. Let me put my cursor over here. Well, if you want to learn about this, you can always get help about the foreign key. So this is the foreign key. This is the name of the key, which is this department number, references. This is the department table, and this is the name of the field in that department table. And by stroke of luck, both the fields have same name. They can have different names. Okay, oops. Well, dear students, I have another table that is the sal grade table, which is having the grade key, which is the primary key, and two fields, the low salary and the high salary. Let me move down. So now we have the tables created. We have some insertion statements. You can see I have inserted data in the sal grade table. You can see these values over here. You can use one insert statement and can enter multiple records. Then I have inserted certain data in the department table, and over here I have inserted data in the employee table as well. Well, let me quit this, and now let me execute this script file so that all this is done automatically. And for that, I am going to use the source command videodb.sql. So this will execute all the statements in that file, and you can see right now I'm using videodb. Let me show you tables. In this we have 3 tables. Describe the department table. So this is the department table. We have created it before manually. And this is the employee table, which contains employee number, e-name, job, hire date. And remember this, the data type of hire date is date, and you can always get help about this data type date. So the rate supported range is this to this and so on. Please do read these help pages whenever you are stuck up somewhere. And finally we have the sal grade table. So this is a sal grade table having the first field as grade, then we have two fields, low salary and high salary. Let me clear screen and let me select all the records from the department table. So it contains 5 different departments: accounts, research, sales, defense and operations. These are the locations. And let me show you the employee table as well. So these are the 14 entries in the employee table. Rauf is the president, we have clerks, we have salesmen, we have analysts, managers. These are the hiring dates and whose manager is who. For example, Mohid 14, that means the manager of Mohid is Farhan. These are the salaries and these are the commissions. Some persons are having some commissions like 2000. Mohit is having a commission of 2000, and some are not authorized to have any commission. For example, managers, president, they are not supposed to have any commission. And this is the foreign key. You can see Mohit has a department number of 5. So let me show the department table as well. Okay, fine. If Mohit has the department number of 2, so that means he belongs to the research department. If Mujahid has the department number of 2, okay. If Farhan has the department number of 3, that means he belongs to sales department. So this is how the parent department table and the child employee table are related to each other. Okay, so now let us move on and see how we can work with the select statements. Let me show you the distinct keyword that can be used with select distinct job from EMP. You can see these are the distinct jobs. If I don't use distinct over here, excuse me, you can see all the entire job column is displayed, in which it has a lot of repetition: salesman, salesman, salesman. But over here you can see just the distinct values which are being displayed. Okay, so this is one thing. Well, if you have a very big table, select all from EMP. So if table has just 14 records, you can see it in one screen. If it has hundreds or thousands of entries, you cannot see it in one screen. So you can limit your output using limit, let's suppose 5. Only 5 entries are there. And if you want to see from 6 onward to 3 more records, so you will see 3 more records. This 5 is not inclusive. Okay, where is a very simple class that is used to filter records. Let me use where. Select ename job salary from employee, where job is equal to, let's suppose I want to just see the salesman. Oops, I have some issue somewhere. Select ename job. Sorry for the typo. So these are just the salesmen that are being displayed in front of you. You can use different operators. Over here I have used the is equal to operator. There are a lot of operators that are available to you. Let me use help, contents. These are the contents. Let me go into functions, help, functions. These are the functions which are available. With functions, comparison operators, as comparison operators, help, comparison operators. So these are the comparison operators that are available to you. And if you want to get help about, let's suppose, not equal to operator, you can see the behavior of not equal to over here. So let me clear screen and let me use select all from employee where the hire date is greater than. Let's suppose I just want to see those employees who have been hired after 2012. So hire date will be having all the three values, day, month and year. So let me use the year function over here. Okay, so these are the employees who have been hired after 2012. And if instead of the year function I just want to use the month function, I just want to check out all the employees who have been hired, let's suppose in the month of 5. So you can see these are only the employees who have been hired in the month of May. Okay, dear students, similarly you can use other operators. One common operator is the between operators that is used to check for a range of values. Let me clear screen and say select all from employee where salary between, let's suppose 35,000 and let's suppose 70,000. So this will just show those employees who have salaries in between this range. Another operator that is very common is the like operator, and the like operator is used to search for a pattern. And while using the like operator, you can use the percentage sign that can represent 0, 1 or multiple characters, and you can use underscores to represent a single character. Let me use the same query, select all from employee where ename like, let's suppose I just want to see only those employees who have their first letter in the name as A. So there is only one employee. And if I want to see those employees who have 4 character names, I just put 4 underscores. You can see Rauf, Mars, both these employees have 4 character name. And let me change, let me say that I just want to see those employees whose second character is A. So this will work for that. You can see Rauf, Jamil, Mars, all these employees have second character A in their e-name. Okay, let me clear screen. The next operator is in that I want to talk about. In is an operator that is used to specify multiple possible values for a column. Suppose we want to select all the employees who are either clerk or salesman. So select all from employee where job is equal to clerk. This will work only for clerk. Sorry, we have an issue. Let me quit. Let me give this command again. Sorry for this. Let me use the video DB and let me repeat that command again. Select all from EMP where job is equal to clerk. Okay, so but I want that all the clerks as well as the salesmen should be displayed. So instead of is equal to, I'm going to use the in operator, and I'm going to give comma separated values which I just want to be compared. Salesman. Okay, so now you can see all the clerks and the salesmen are being displayed in front of you. Well, we have the logical operators as well, and if you want to get help about the logical operators, you can just type help logical operators. So this is the not, this is the and, this is or. I'm right now interested in these three. Let me get help about the and operator so you can read this. Let me clear screen and let me use a query that use this operator. Select all from employee where, let's suppose, the hire date of the year of the hire date is, let's suppose, greater than 2008, and let me say, and you can write down this as well, and job is equal to salesman. Okay, so this says select all those employees from the employee table who are hired after 2008 and their salesmen. So you can see all the salesmen who have been hired after 2008. Similarly, gentlemen, you can use the other operators as well. Let me move ahead and talk about the null values. You can always compare the null values as well. Okay, we have a break for namaz. Okay, dear students, welcome back. We have a short break for the namaz. Okay, before the break, I was talking about the null values. Well, yes. Dear students, if a column contains null values, we cannot use the comparison operators like is equal to and not equal to. Rather, we have to use is null and is not null operator. Let me show you with example. Select all from employee. See this table. Let's suppose I just want to display only those fields or those records in which commission is not null. So I will say select all from employee where com is not null. You cannot use is equal to over here. And if I want to see the columns which are null, you can use like this as well. Okay, so let's move ahead and let's talk about MySQL functions. MySQL has a rich set of functions that are available to you. You just need to know how to use help regarding functions. So these are a lot of functions: the bitwise functions, comparison operators, control flow functions, numerical functions, string functions. Right now, I'm just interested in the aggregate functions. Remember, the aggregate functions are functions that retrieve a single value after performing a calculation on a set of values. And the most common are the min, max, average, sum, and count functions. Let me show this to you. Let me use system clear. Select all from employee. Let's suppose that I just want to find out the average salary of all the employees of this company. So I will use select average salary from EMP. So the average salary is 42,500, and if I just want to check out the max salary, you know it is 1 lakh, and that is of President Rauf. And if I just want to find out the minimum salary of a clerk, suppose I can say select min salary from employee, and let me filter it out where job is equal to clerk. So the minimum salary of a clerk is 15,000. You can use these functions as you deem necessary. Let me move ahead and think of another statement that is used to sort the output of a query, and that is the order by statement. Let me select all from employee. And let's suppose that I just want to order this output by ename. So I will say select all from employee, order by the column ename. You can see now this is ordered alphabetically ordered. And if you want to see it in descending order, just write down descending over here. So it has been in descending order. You can see a deal at the end. So after order by, we have the group by statement, and this group by statement is often used with aggregate functions, like we have talked about the count, min, max, sum, and average functions, to group the result set by one or more columns. Let me clear screen and give you an example of this. Let me say select job and the count from employee table, group by job. So what this query is going to do, it is going to display the job and the count of all the employees and will group that count with the job. So you will come to know that we have one analyst in our company, 2 clerks, 2 managers, 1 president, 6 salesmen, and so on. Whenever you are using the group by statement, remember all the columns that are there in the select list and are not part of an aggregate function, they must be in the group by clause. So we have job over here, that has to be over here. If you have 2 columns over here, those 2 columns should be there in the group by clause, separated by comma. Moreover, the group by column, this group by column doesn't have to be there in the select list. So whenever you are practicing group by clause, keep these 2 points in mind. Let's move on to the having clause. Dear students, you cannot use a group function in the where clause. And if you want to use a group function, instead of where clause, you will use the having clause. Let's suppose that you want to list only those jobs which are being done by multiple employees. Let me say select all from employee, and let me repeat it again. I just want to list only those jobs which are being done by multiple employees. So that means clerks, that means salesmen, that means managers. So these are the jobs which are done by multiple employees. You can find it out from this table because it has only 14 records, but if this is a huge table, you need to use a query for that. Let me write that query for you. Select job and the count of the jobs. Let me move on to the next line for better understanding of the query. From EMP, group by job, and having count greater than 1. There you go. You can see only clerk, manager, and salesman are there. And you can see that we have 2 clerks, 2 managers, and 6 salesmen in our company. Okay, let me clear screen and talk about the joins as well. Well, this join clause is used to combine rows from 2 or more tables based on a related column between them. And we know we have 2 related tables. Let me select all from employee, and let me select all from department. These are the 2 tables that are related to each other. Please note that Rauf, who is the president, does not belong to any department number. And over here you can see that department number 4 is defense, and there is no employee who belongs to this department in this table. Okay, keeping these 2 points in mind, let me talk about joins. First of all, the inner join. Dear students, if you joined 2 tables using inner join, it will select only those records that have matching values in both tables. Let me use this example. Since there are 2 tables now, let me use the prefix emp.ename I want to select the ename column from the employee table and the job column from the employee table and the, let's suppose, location column from the department table from emp. So this is the left table, inner join dept. This is the second table, that is the right table. On emp dot department number is equal to department number. Okay, so what I am saying is I need to select these two values from the emp table, this value from the department table, and I want to join those two tables using the inner join based on the primary foreign key. Okay, so you can see we do not have president from the left table, and we do not have the sales department, which is located in, where it is located, in Quetta, and nor we have the entry from the right table. So inner join, it will select only those records that have matching values in both tables. Let's talk about the other join, that is the left join. This left join make minor change in this query. You just have to use inner join. Instead of inner join, I'm going to write left join. And if I use a left join, you can see now the value, the non-matching value from the left table is there. Row, the entry row is there from the left table. That is why this is known as the left join. All the records from the left table are there. And remember, the left table is the table which is written after the from clause. And if I use the right join, this time you can see in case of right join, we have this quota over here. The record from the right table is there. So in case of inner join, only the matching records will be there. In case of left join, all the matching records will be there, as well as all the records, all the remaining records from the left table. In case of right join, all the matching records as well as any other record from the right table is there. Oh, in case of full join, all the records from both the tables will be displayed, and we do have the self join as well. And for joins, let us move ahead and talk about the concept of subqueries now. Well, you can embed a query within a query. The inner query is also called the subquery or the nested query. And the result of the inner query is used in the main query as a condition to further filter the data. Suppose we want to find the employees in the company who are getting the minimum salary, or who is getting the minimum salary. Let me just say select all from emp. From this table, you can easily find out that this person is getting 15,000. Who is this? This is Kamal. So Kamal is getting the minimum salary, 15,000. I can always write down the query now. Select all from employee where salary is equal to 15,000. You see the result of Kamal is there. But what if this employee table is having thousands of records? In that case, I need to write down a query at this place which will give me the same output. Okay, so here comes the subquery. Select min salary from emp. So this is a subquery. The value 15,000 will be placed over here and it will be compared with this, and you get the same output. Well, dear students, if the inner query, this query, is returning multiple values, then we cannot use greater than, less than equal to operators. In such a case, we have two more operators, that is any and all. Well, any operator returns true if any of the values returned by the inner query meet the condition. Let me give you an example. Select all from, let's suppose, department this time, where department number is equal to, and let me say that I want to uh, show the data of that department only which have clerks in them. So I need to put those department numbers over here who have clerks in them, and the query for that is select department number from emp where job is equal to clerk. So sounds simple to me, but there is a possibility that this query select department number from employee where job is equal to clerk might return more than one value. So in that case I have to use any over here, and this any will return true if any of the values returned by the inner query meet the condition. Oops. There's some typo. Select all from department where department number is equal to any. I have missed is equal to over here. Okay, so we have these two departments who have clerks in them. You can check out department number 3 and 5. So this department number 3 has clerk, this department number 5 has clerk, department number 1 has salesman, manager, senior manager, and so on. Let me show you the query again. Select all from employee from department where department number is equal to any of these, and if we talk about all, you can use the same query for all. Let me write down all over here. This is another operator. All returns true if all the values returned by the inner query meet the condition. All of them must be true, and let me put a not over here, and this will give you the same result. Well, there can be other ways to get this result. My objective was just to tell you about the subqueries and the use of any and all operators. Let us move on to the next topic, that is views. Okay, dear students, a view is a virtual table, and that is based on the result set of an SQL statement. We can have two types of views. One is known as a simple view, which is based on one table and does not contain groups of data or functions, and it normally allows DML operation, that is, you can do insert, update, and delete on simple views. The other is a complex view. A complex view normally derives data from many tables, and it can contain groups of data and functions, and normally it does not allow any DML operation on it. The points to be kept in mind is that if any data is changed in the underlying table, the same change will be reflected in the view. So enough of theory. Let's create a simple view. You can create a view using create view statement, and let me name the view as empview suppose 1 as select emp number, name, job from employee. Let's suppose let me filter it out with department number is equal to 1. Oops, you have created a view successfully, and if I show the tables, you can see this view is there. So this view has been created. If I say select all from empview1, the view is there, 4 employees record, and they all belong to the department having department number 1, that is the accounts department. Okay, you can always alter this view, you can rename this view, you can change the data in the underlying table, and that data will be reflected in this view. And finally, you can always drop this view. You can drop this view, drop empview1, and once you have dropped it, the name of the view is correct, empview1. Yes, I have not placed drop view over here. Okay, so if now I see show tables, you cannot see the view over there. Before moving ahead, let me create a complex view as well. just to give you an example. And we know that complex view contains the min, max, and average functions. Let's create a complex view that display the minimum, maximum, and average salary of each department with department name in front. So here we need to get the data from two tables. We need to get salary from the employee table because we want to get the minimum, maximum, and average salary. And we need to show the department name as well. So we need to get this information from the department table. So this will be a complex view. Let me write down create view. Let me name it department sum underscore view. Let me move on to the next line because this will be a long query as select dot dname, because we have two tables now, and I'm prefixing the field name with the department name. Select department dot department name and min emp dot salary, max emp dot salary. You can use aliases with these field name, and average emp dot salary. Hope I have not done any typo. Let me move to the next line. From emp, let me use inner join with this department, where emp.dept number is equal to dept.dept number, and let me group by department name. Oops. As usual, I have done typos. Let me check out. Create view. This is the view name as select department.dname, min emp.salary, max emp.salary, average emp.salary. Then we have from emp inner join dpt, where emp.department number is equal to department.department number, and group by. Okay, this is the issue. Okay, now let me use show tables to see the view. The view is there, and let me do select all from dept under the underscore sum view, and here you go. Here you have the department names which are coming from the department table, and the min, max, and average salary which are coming from the employee table. So this is of course a complex view, ladies and gentlemen. Okay, so next topic. Next topic is about MySQL transaction. Well, dear students, a transaction is a logical unit of work that contains excuse me, one or more SQL statements. It is an atomic unit that can be committed or rolled back and is used to follow the ACID model. By ACID I mean A means atomicity, C means consistency, isolation, and durability. By default, the MySQL server works in auto commit mode. By auto commit mode, I mean every DML statement is committed as it is executed. If you want that no auto commit should be done whenever you give an insert, update, or delete statement, you write down start transaction. So now we are in no auto commit mode. So if we are in no auto commit mode, that means all changes which we have made will be committed only when we will say commit, and if we think we can roll that back. Okay, let me give an example. Select all from department. These are the departments which are available to you. Let me update the department name operations to, let's suppose, just op. Update department, set dname is equal to op, where department number is equal to, and we have 5 department number. Okay, 5 semicolon, and done. And let me say select all from department, and you can see the department table has been changed. But remember, this has not been committed. Let me say rollback. Okay, and let me do select all from department again. You can see that change has been rolled back. In case of a long transaction, you can create save points in between, and you can mention a label for that save point, and later you can either roll back or commit to that save point. Similarly, dear students, you can achieve read and write locks on tables using the log statement. And you should see the help page for lock. Okay, this is a good help page which will tell you how you can create read and write logs on different tables. Okay, well, I am tired. Excuse me. Dear students, I'm tired, so I am skipping few planned things, and I want you to do them by yourself as assignment. And the first thing is I want you to create your own MySQL procedures and functions. You can do it using the create procedure and create function statement. Remember, as in programming languages, a MySQL procedure has a name and a parameter list, and you can call it using MySQL call statement. You can get help create function on this. The other thing I am skipping is triggers. I want you to do create triggers of your own using the create trigger statement. Well, a trigger is a database object that has a name and it is associated with a table. It gets activated or triggered when a particular event like insert, update, or delete occurs on that table. The third thing I am leaving for you to do is creating an event using the create event statement. You can get help on help create event. Events are similar to triggers. The way trigger is executed when an insert, update, or delete occurs for a table, an event gets executed at a scheduled time. And the fourth thing I want you to do is to import data from suppose a CSV file to your MySQL table and vice versa. Well, before doing these four tasks, you should practice this video first, the earlier part. And you should know how to get help from MySQL. If you know that, you will be able to do these four tasks, rather any task that I have not touched in this video. Okay, dear students, we are done with MySQL. Actually, I just wanted to do the installation, configuration, and the user management part. But due to a long free weekend, I thought of spending a little bit more time on this topic. But I'm sure this video has gone too long than my expectation. I hope this session was informative for you all. If you have liked it, please subscribe my YouTube channel and share it with your friends. Happy learning and Allah Hafiz.